First of all, we titled the session The Economic Benefits of Cyber Resilience, but really the project is around the methods and the tools that we used to take from concept through to a realization. But perhaps could you, as a panel, try and characterize for us as we look forward beyond the end of this project, what the economic benefits of this approach could be versus a more traditional approach to cybersecurity?
Shall I take that one?
Yeah.
So I think the reason we spoke about it in terms of economic benefits, so traditionally people look at cybersecurity and they talk about how much security do I need to do, and it's sort of handled in that kind of way. But one of the things that we were demonstrating as part of this was that many cyber attacks that we're looking at are emergent properties. But many emergent properties are the things that you rely on for benefit. So very few people design things knowing absolutely what will be the positive things, what will be the negative things going forward. And that's particularly true as we move into more connected transport systems and things of that nature. So this idea that actually what you're looking at is looking for emergent properties, some of which will be negative, some of which will be positive, but actually capturing what you need in order to move things forward beneficially. Yeah. And as a spin-off from that, you're actually getting a lot of these cyber results as well, is what we meant by economic benefits. Yeah. So you can see that, for instance, where you look at the industry's move to using vehicle dynamic simulators and things rather than setting things up manually. There's cost benefits, there's time benefits from doing those sorts of things. And that is increasingly what you're seeing. So the right way of looking at this is when you're looking at cyber attacks or you're looking at emergent properties, instead of having a situation where I designed it all up front, we are continuously in a situation where we're in a prototype. Yeah, so essentially, the technology readiness level of an emergent property is usually zero. So essentially what you do is keep getting into your prototype phase, keep getting into your opportunity to take the positives out of that, to do the right things. The investment you make in these tools and how you use them, if you do that correctly, will actually give you real economic benefits. Conversely, if all we do is go, okay, I've found another 10 problems, and I'll just add that to my compliance thing, then I think one of my fears there is if you do it that way, that is the unsustainable cost. That's what gets you your 75 billion a year incapable of getting all of the things that you need to do. It's what will get tested in court in relation to that. It's like doing fractions with nothing on the bottom. So I found another 10. Yeah, but it was 10 out of infinity, so it didn't make any difference. Yeah, certainly not to my attackers. So that aspect to start to get ahead of this and start to treat it as engineering instead of treating it as a cottage industry that we can never scale to was really what I think and what I mean by economic benefits coming out of cyber. I think it's really important that we start to look at it that way. Yeah, this is modern engineering of connected systems, and that's what you have to do for modern engineering of connected systems.
Yeah, I think it's really important as well to add to that as you demonstrated in the initial slides, the scaling of the existing processes actually don't work at that scale. The 500,000 cyber engineers, we're not going to get to that position. So we have to approach a different technical approach, different solution set to this to address those problems and modes to make the transportational benefits, the operational benefits of the 21st century vehicle objectives that we have economically viable and achievable.
I think that's a great point. I think one of the things with the group that we have in WMG is we've talked for a long time about resilience rather than just security, which is really protecting something. It's protecting the safety of a vehicle or whatever you're doing. But really, as we move to resilience, it takes us away from that notion as security as a cost, something that you've got to do. Sometimes at the end of a process as well, it's not very integrated. But if we just think about developing resilient systems, we can see that continual improvement. We can see the emergence of different attacks happening, but we can do continuous improvements throughout. And that helps us recognize that the lifetime of something can adapt over time. And I think that's where we're getting a lot of traction with organizations that we work, that we're saying it's not just about some cost and some protection. There will be something that comes along to compromise your system. It's how you deal with that that's really important. If you engineer that right, using these processes that we've developed over a number of years and a number of projects, this will help you realize something that's more sustainable, a word that Peter used.
Yeah. I think just to add to the using the resources effectively point, as we know, cybersecurity and cyber resilience is now a regulated area for the automotive world, and being able to adopt the tools smartly and use these approaches to avoid turning it into simply a compliance problem that involves huge amounts of resources, but potentially not focusing the effort where it can make the most benefit. That's very, very important for us.
Okay.
And some of the transformations that we're talking about needing as well requires an adaptation in the industrial engineering process. So the automotive manufacturers, the OEMs, need to move into the 21st century to address the technical challenges of making a connected cyber resilient product rather than making a completely isolated product that they're used to at a drumbeat driven delivery mechanism of a new model, a new launch that we test and validate. These products have to be sustained on an ongoing basis, just like mobile phones, just like the connected consumer services that people are becoming increasingly used to and dependent on. This has to be adaptive constantly and requires a different set of operational business practices ultimately.
Okay, thank you. Our next question. On the slides, we could see that we've got this automated process. It's a kind of closed loop feedback system, which means that we could be potentially providing updates to a vehicle on a regular basis, minutes even in some instances. What implications do you think that capability would have, for example, on regulation and in particular type approval?
So I could start that one off maybe. So as we've said, cybersecurity is now subject to new regulations. So we have new UN type regulations affecting vehicle type approval, and they're placing new requirements, particularly around the area of detecting and responding to emerging attacks. And as we've seen, these cyber attacks are we consider them as emergent properties of systems, and therefore we don't necessarily know in advance what they're all going to be. So we need to find ways of understanding what detecting and understanding and responding to emergent attacks means for vehicles and for connected mobility. And the tools investigated during the project give us some means for doing that at scale and in an automated way, because another of our requirements from the regulatory side is also to be able to respond in a timely way, so shrinking that time down from hours or days down to minutes. So it's very important that we look at the automated tools of the kind that we've been looking at in the project to help us do that at scale.
I could probably chip in some of the stuff that Brian would have wanted to put in here from the legal perspective, which was when we're looking at the compliance that goes with this stuff, that does not entitle you to. There isn't a way by which you can set aside the law. So we have a law of the land that's based on health and safety and things of that nature, and I think some of the observations that we came out from with this is. If we don't have regulations that can be effectively operated, that can be effectively used, then actually society reaches for the law. So imagine having to do an ALUP, so doing not just this was reasonable, but this is a situation where this is everything you could have done, and you get into the same sort of situation as they had on the 737 MAX, which is. We'll take 18 months to get it back in the air, or 18 months to get it back on the road. Imagine that in the face of 250,000 cyber attacks in relation to that. And the other thing that I think was really important there that the team demonstrated, we were not demonstrating faults based on software updates. We were demonstrating things that happened in the environment. And that I think is a really important thing. So I think where we've got to on the compliance. As we stand in the regulations, is a really good starting position. But as Jed was saying, if you try and push that along and carry on doing that, then it won't take into account all of these sorts of things. So we hope that what we've done is demonstrated from a legal point of view, from a compliance point of view, how those could be developed in order to be much more real time and in order to be looking at these things as you're going along.
Okay. I've got a question about the resource again, because we talked on that on the slides, and you've mentioned it already a bit there, Jed. What implication do you think these processes, these tools have for resources in cybersecurity?
Yeah, okay. So, as we've touched on already, the kinds of transformations that we're going to need will bring a demand for a reactiveness which completely contradicts current customer practice in automotive design. So we've got a business transformation that we need to make in conjunction with a set of technical challenges which are new and emergent in the sector. So rather than taking at face value the demand for 500,000 cybersecurity people, and just to put that into context, that's more cyber people than we have working on automotive software globally currently. So that's kind of one cyber person to every programmer that's being utilised to create the control systems in the vehicle. We need to make a reassessment of that paradigm, wind it back to the challenge now is not the classical automotive produce a vehicle for personal use operated by the driver, their liability, their responsibility. This is the car needs to, or the vehicle in question needs to be self-capable. The control structures that it deploys need to be robust in that environment, and they need to be modifiable to the kinds of timeframes that the project investigation has identified. Few minutes reaction time to identifying poor, bad behaviour, badly defined behaviour. A reaction to it has to be validated, created, and deployed back to the vehicle in that time. This is entirely only achievable through automation, and requires not only in the management systems that will make those dictates to the fleets out there, but also in the design processes that set the vehicle up to be controlled in that way. All of these things have to be routinely automatic. As I mentioned earlier on, not just, we're going to, in 4 years' time, we're going to come out with a new model, so we'll start now, we'll do 3 years' worth of testing to validate the integration, and then we can sign it off at that endpoint. It's that transformation in business operation that says, the vehicle I put to market, we'll stick with the model year-oriented things, but when it goes to market, it's going to continue to develop and evolve. And as we know, the current masters of this are Tesla. Their marketing material reference them as the only car that gets better the longer you own it. But we have to be able to do that across the entire spectrum of transport.
Okay, thanks very much. I think we've got time for maybe one more question. This is a more general one that I've got, really. What do you think, well, to me, it's been quite clear through this project that the UK is in a leading position when it comes to cybersecurity. Excuse me. What do you think the UK needs to do to exploit that position as a world leader?
So I'll take that. So I've worked in this area for quite a while, and we did a review of the UK position quite some time ago, supported by former Chief Scientific Advisor to DFT. And with some of the ideas that we've developed in all these projects we've had, we've come up with a set of suggested routes for exploitation and a roadmap for that, building upon the work we've already done. Unfortunately, one of the things we have to do is start by finance. There is a need for funding this. It will generate significant economic benefit to the UK. There's a real opportunity to be a world leader, I think, to create the tools and to collaborate together. We've got a fantastic ecosystem here. In some of the workshops over the programs that we've run, working with a number of organisations, Automotive Council, with ACIN, research institutes, we've had literally hundreds of people come together, including NCSC and other parts of government. And that collaboration is something I don't see. So I go across the world to see what's happening in resilience and security in automotive, and I don't see that elsewhere. So we've got a fantastic opportunity to develop the tools, and we've done some of that within the project so far to create a sovereign IPR, so something that we can work on and we can license for us all to use, to work with academia and research institutes. And that is one thing. We have 19 academic centres of excellence in cybersecurity research in the UK. Some real world-leading thinking, but many of us are very committed to working with industry and coming to panels like this. And that's really important that we capitalise on that. And that's what we're going to have to do if we're going to address this skills problem that was mentioned. And what we need to think of is not that there's 500,000 cybersecurity engineers, but all engineers are cybersecurity aware, cyber resilient. It's got to be part of what we do. I work with a number of regulators in many different sectors, and the UK, I really honestly think is a world leader in regulation. We've done some fantastic things. Consumer IoT security that we've been working on, you know, that's become a model across Europe and across the world. We can do the same here. We've got good relationship and good innovative regulation. And I think together those kind of techniques give us a great platform from which to build for the future.
Yeah, I guess just adding to the regulation point, the UK has been very much in a lead role in developing the new UN type approval regulations, and also in the future of safety and security assurance through the CAVPAS scheme. And there's now a huge opportunity to take some of the strong technical capabilities we also have and start pushing those into more international regulatory and standards activities to put these capabilities and make them available to the global market that they need to be.
Yeah. And I think adding to all of those points, Carsten just mentioned it as well. You know, the control of the environment is as significant as the cybersecurity. Your circle of interacting roles and services is crucial. None of these things work on their own. So the cyber detection and classification is crucial, but the ability to safely and robustly react to it places a significant delta in the demand on controls engineers, who are much cheaper and much more readily available and much less contended than cybersecurity personnel are as well. You get the last word here, I think, Peter.
And I think, so firstly, I'm heartened by the fact that people like the US have actually been coming to us for their advanced cybersecurity training. And I think the other one that goes with it, we have shown in the tool how you can keep up with the environmental stuff. So you have that evidence, and if you choose not to have that evidence, what we need to do is put the other part around that, and we have that capability. As my colleagues have been saying, we have it in academia, we have it in the industrial base, we have it in our insurance, we have it in our regulation. We are actually in a position to take the leadership position here, and it is a significant market.
Okay. Thank you very much, gentlemen. We're going to have to close there. We're out of time. It just remains for me to thank you all for that panel session. Some really illuminating answers there. I would encourage you